combination of transformation of the functions, you can understand it this way. So if we have an original function is f equals y, y equals fx, so we can assume there is a point called x0, y0, where it actually can be any point on the original function, so that we have y0 equals f x0. So if it transforms into this kind of function, y minus k equals a and f, then b x minus h. So you can try to look at it this way. So divided by a on both sides, then you can transform this function into this form. You can see everything here is something to do with the y. Okay, just make it clear, there's nothing else on the right side except the f plus the bracket, and then everything inside bracket you don't change it. So then if you look at this, it's really like the original form, like y equals fx, except that there's something else here and something else here. So the function works really like a machine. So you see, if this is the function f representing a machine, basically according to the original definition, is if you feed the machine with x0, so that's the input, so you should produce the y0 as your product. Okay, and then how the transformation works is you can really think about this way. So this time if I feed it with x, see if I can make this one produce x0, because that's really the things that feed it into this bracket. If you look at the original one, it just should be the x0. So if I can make this one, and after the operation and change it into x0, and then you should still produce the same y0. And then if you feed the y0 to just another component, so you can eventually convert it to y. So if that's the idea, basically means if you put x0 in, you definitely should get the y0 out, right? So basically, if you look at it here, it's very comparable to the original function. Is whatever you make this the part inside of the bracket being x0, and then you must produce y0. Right? So compared to the original function, and then that means if this one equals x0, so we can just simply write b bracket x minus h equals x0, so that's exactly here, and then this part has to be y0. Okay, and then we just try to work backwards to isolate the x. So you can see you divide by b on both sides, you get this, and then you plus h on both sides, so eventually isolated x equals x0 divided by b plus h. And same thing for the y. So this part equals y0, so we isolate all the way, y equals a y0 plus k, right? So basically, if you look at this one, so x is really represents the new point, the x coordinate of new point. It has this kind of relation with the original point divided by b plus h, right? And then y equals a x0 plus h really means you have to do the multiplication with the y0 and then plus the k, right? So if we describe this using the transformation term, we can look at the example. So if the b equals 0.5, negative 0.5, h equals 2, and look at it here, basically the original x coordinate divided by the negative 0.5, now since the b is negative, so you have reflection. And then divided by 0.5, it's equivalent to multiplied by 2, so it's a horizontal stretch by a factor of 2. And then after you've done that, plus 2 means you have 2 units to the right, right? So the x increased by 2, so 2 units to the right. And if you look at the y vertical direction, so if we make the a equals same, negative 0.5, k equals 2. So according to this one, a multiplies the original y coordinate. Because negative, you can also see there's a reflection, and then compressed by a factor of 2. But it doesn't really matter the order between the reflection and its compression, right? So because they're basically both a multiplication, you can switch the order. But you can't switch. You can't start with 2 units up though, because according to the operation, you have to have the multiplication done first, and then do the addition. So when you add 2, and that means you have 2 units up, right? Because the factor is the new y coordinate as 2 units increased by 2 units. So of course it's a translation 2 units up.